Okay, so just want to make a short video walkthrough for problem number 3 here on the part 2 worksheet. And so I think you can read that, sentence there, the problem. So this pipeline is built, it's going to accommodate expansion and contraction. If it isn't built that way, it's going to break. So here's what it is. Suppose a 600-foot section of pipe, and here's your 600 feet, right? When it's going straight across, that pipe is 600 feet long. But it expands 2 inches and it buckles. It expands 2 inches and it buckles. So we want to estimate the height of the buckle. And the height of the buckle is the H right there. And so basically what happens here is on both sides of the buckle, right, it's like a right triangle. So there's a right triangle on the left. Here's a right triangle on the right. And so we can use the Pythagorean theorem to try to figure out what H is, right? And you don't need both the right triangles, you just need one of them. But I just wanted to point out that's what happens when this buckles. It shifts up and it's creating these right triangles for us to work with, right? So I'm going to focus on the one on the right. By the way, also, I wanted to highlight the 600 feet of pipe. The 600 is not important here since the buckle, cuts the 600 in half, and we see the 300 feet on the dimensions of one of our right triangle. And so I'm going to erase the 600 as well. I just wanted to point that out. We're really going to work with this 300. And again, the reason is once the buckle occurs, we have a right triangle, right? So I'm going to draw that over here a little bit. So here's our right triangle, and this is 300, and this is H, which is obviously what we want. And then that hypotenuse, and I know it's the hypotenuse because it's across from my 90, is 300 feet and 1 inch. And that's really the tricky part of starting this problem and where maybe a lot of the errors are going to occur. The problem is we have 2 units in one number, right? 300 feet, 1 inch. If we want to do all of these problems, we have to keep the units the same. And now we got to decide which one we're going to use, right? Are we going to use feet or are we going to use inches? And we're going to want to use feet because the other dimensions we know also use feet. So really the trick to this problem is we need to turn that 300 feet 1 inch into just feet all by itself. And so here's one thing we want to know. There are 12 inches in a foot, right? And so 1 inch is 1/12 of a foot. And so let's take our calculator and let's turn that to a decimal. What happens if we do 1 divided by 12? And so when we do 1 divided by 12, we get 0.0833 repeating, right? And so in a decimal way, right, this is 300 feet and then 0.08333 repeating of another foot, which means we can just kind of tack that 0.083 onto the end of our 300 feet. What I mean by that is this. This is 300 feet and 1/12 of a foot. We know 1/12 is 0.083 repeating. And so 300 feet and 1/12 is the same as 300.083 repeating feet. And so now we've converted that double unit dimension into one single unit. We changed it all to feet. And so now we just want to perform the Pythagorean theorem and we'll have our answer. So remember, C is always our hypotenuse across from the 90. And so our setup for the Pythagorean theorem is going to be h squared plus 300 squared equals 300.083 repeating squared. Now, that can be kind of hard to deal with, so I want to go to the calculator again here. So the 300 squared, a little bit easier to deal with. If we just type that into our calculator, we are going to get 90,000. So this is going to be h squared plus 90,000 equals whatever 300.083 repeating squared is. So let's talk about that one. I'm going to type 300, and then I am going to go up on my calculator 3 times till I'm highlighting the 0.083 repeating part. And when I hit enter, it kind of tacks it onto the end of my 300, right? So now it's kind of displaying it as 300.083 repeating feet. And that's perfect because that's what I want. And now I can square that number. And then when I hit enter on that, I get 90,050.083 0.0 blah, blah, blah feet, right? So I'll call that, I'll just write all of that down. 90,050.00694. 90,050.00694. And now I got to solve for h. So I'm going to subtract 90,000 from both sides. And when I do that, I get h squared equals, and it just leaves us with this left, right? 50.00694. And so then lastly, I need to square root both sides. And so my height is going to be the square root of that 50 number. And so I'm going to go back to my calculator just to get it without rounding. Remember, I just subtracted 90,000 from this number. I'm going to do that again on my calculator. 9,000, 90,000. Boom, right? Leaving us with 50, whatever. So then I'll hit second, and I'll get my square root symbol up there, and I'll hit up again and highlight that number. And when I hit enter, it'll put it under the square root. So now I am taking the square root of that number, and when I hit enter, I get 7.07. And so the height of that buckle is 7.07, and because we made our units consistently feet, it is 7.07 feet. And that should be the height of the buckle when the pipe expands. So I hope that walkthrough helped you. Please let me know if you have more questions. Thank you very much.